Welcome to my video, QGIS for Geoscientists. This video is an overview of how I use QGIS in my day-to-day geological activities, and it's not intended to be a comprehensive coverage of all QGIS features, but it will give you an idea of the capabilities of QGIS. I'm a geologist with over 40 years experience working in the exploration and mining industry, mainly in Western Australia, but also in Brazil, China, South Africa and Tanzania. During the past few years, I've been running workshops designed for geologists on behalf of the Australian Institute of Geosciences. There are plenty of online tutorials for QGIS, but in general, nothing specifically caters for geologists or geoscientists. This video will give you an overview of QGIS and the range of geological tasks that QGIS can accomplish. It's a very powerful program with a large range of applications in the world of GIS, and I'll only be discussing the tasks I have found useful in my day-to-day geological activities. I'll give a brief introduction to what is GIS and the QGIS project. So GIS stands for Geographic Information System. GIS programs are a way of displaying data points that are located on or in the Earth. There are two main types of spatial data, vector and raster data. Vector data comprises points, lines and polygons, and raster data are grid data or images. Vector data can be described as a single XY coordinate point, and a series of XY coordinates to form lines, or a series of XY coordinates that form a closed shape, which is known as a polygon. Raster files comprise data with XY coordinates for their cells or pixels, and values at those coordinates. They can be grids of elevation, or they can be image files like process magnetics or satellite imagery. The real value in GIS, particularly for geological applications, is the ability to overlay a variety of data sets. For example, aerial imagery, geophysical data, roads, tracks, rivers, drill holes, and so on. These data sets not need to be in the same map projection or datum as the GIS program will reproject the data into their correct location with respect to the other data sets. The official QGIS user guide and training manuals are available from the QGIS website in the documentation section. As a spin-off of running the QGIS training for geologists, I'll put together a manual on using QGIS in mineral exploration. This document covers topics that are not readily found by QGIS Google search. This document is free to distribute, as the more users we have using QGIS, the stronger the community will become. The document covers geological type tasks like plotting oriented structure symbols, adding geological symbols and patterns to your maps. Now, this can be downloaded from my website by going to the QGIS tab. QGIS is an official project of the Open Source Geospatial Foundation and is licensed under the GNU Public License. Developing QGIS under this license means that you can inspect and modify the source code and guarantees that you will always have access to a GIS program that is free of cost and can be freely modified. QGIS is available for Windows, Linux, Macs and Androids. QGIS is a volunteer-driven project, and the project welcomes contributions in the form of code, bug fixes, bug reports, and contributions towards documentation. Donations from corporations and individuals fund the continued development of the core GIS program. And if you find QGIS useful and saves you or your group money, please consider making a donation to the QGIS project. The information is on the website. QGIS is open source software, and as such it integrates well with other open source softwares. PostgreSQL is a very powerful relational database program, strong worldwide support. PostGIS is a spatial add-on to PostgreSQL, and together form a very powerful basis for any spatial database project. Spatialite is a single file database that spatially references its data. This allows for faster redraw when viewing large data sets. The GeoPackage file format for QGIS is based on a spatialite structure. GRASS, that stands for Geographic Resource Analysis Support System, is a fully featured standalone GIS analysis program, as is Saga, System for Automatic Geographic Analysis. This is also an amazing piece of software, again, both free and open source. And many of the GRASS and Saga algorithms are already integrated into QGIS. You can also run R scripts if you use R in your day-to-day work. They can be run from within QGIS. To download and install QGIS, go to the downloads page on the QGIS.org site, and you'll be presented with 3 different options to download QGIS. There are also links to Android programs for field data collection for tablets and phones. In the Windows download options, there are both 64 and 32-bit options. The top option is a network installer. This is a sort of a more advanced download option where you can determine which various packages you want to install with the QGIS software. For most users, I would recommend using the standalone installer, which installs all the necessary bits and pieces into your program files folder. Again, there's a standalone, the latest release version. This has got all the latest versions, latest sort of updates. Whereas the third option is the long-term release, which is the most stable version, but may not have all the up-to-date features of the standalone version. In the Windows install, the installation process will put a folder on your desktop with a number of files. The file you want to run is the QGIS with grass, as this loads all the grass and saga algorithms when you load QGIS. If you can't find what you need in the QGIS documentation, the next best go to is Google. Just type in something like QGIS 3 editing, for example, and you will be presented with a vast array of various online both video and text tutorials. One of the great things about open source software is an open collaboration between users. QGIS is no exception, and they have a great online user forum. When you subscribe to the user forum, you can choose from a variety of options, including receiving a daily summary of posts, which lets you know what other users are discussing. Once subscribed to the user forum, you can ask any question you need an answer to, from newbie questions to difficult "how can I do this" type questions. Australian Institute of Geosciences is working on a QGIS website, and also I've got a reasonable amount of data on QGIS on my own personal website as well. The interface for QGIS is similar to most other GIS programs, with the main area of the screen reserved for the map. The left-hand side contains panels showing a directory of available files, which is called the browser, and a panel showing which files are loaded into the map, here called the layers panel. In this screenshot, I've also displayed the processing toolbox on the right-hand side, which gives access to a vast array of different functions. The top menu bar icons also have a wide range of tools to select. On the left-hand side of this example, there's a browser panel. Think of it as a directory listing and shows what files have been recognized by QGIS in your active folder links. The type of files are also displayed by various icons. The checkerboard icon, for example, indicates a raster file, and the blob type icon is for a polygon vector file. The green QGIS icon indicates a QGIS project file. On the right is the layers panel. This panel shows what layers loaded into the map window. Layers can be turned on and off as required, and the type of file is also displayed by icons next to the layer name. Point icons indicate a point vector file, for example. If there is a grid file located, it will display the color stretch with the relevant values for that particular layer. There are several ways to load layers to import them into QGIS. The Data Source Manager, with the icon located in the top menu bar or Control L, will open up a dialog box with a large number of options to load GIS data. You'll most commonly use the top 3 method, vector, raster, and delimited text. Some of the other items like WMS and WFS options will be discussed a bit later. The vector layer option is used to load files such as ArcMap info files. The raster option allows for the import or display of a wide variety of raster file types, and the delimited text option allows the import of text-based files like comma-separated variable CSV and various other text file formats. Projections. The Coordinate Reference System, or CRS, is very important when dealing with GIS data. As the Earth's surface is curved, we have to compute a method to display this curved surface data on a flat map or computer screen. This is where the Coordinate Reference System comes into play. It's essential to know the CRS of your data. If the data is imported using the incorrect CRS, then the data will not plot in the correct position. There are 2 places where the Coordinate Reference System can be set. One is in the Layer Properties CRS tab for each layer. This enables QGIS to plot the point in the correct location in the map window. If the map window is in a different coordinate reference system, then it will reproject the data to plot the data into the correct place relative to the other data sets on the map. The other place to set the coordinate reference system is the Project Properties Coordinate Reference System tab. This determines how the map data are displayed on the map, and it's very different to changing the coordinate reference system in the layer itself. Plugins. Plugins are small utility programs written by QGIS users to undertake a specific task. There are over 700 plugins available, and this list is growing continually. Here is an example of the Data Plotly plugin. If you want to see all the plugins that are available, just click on the All tab. The other tabs there show you what you've installed or not installed. You can also install these plugins via a zip file as well. And one good thing about if you click on a particular plugin, as per the Data Plotly plugin, you'll be shown a link to the author's home page. And if you've got any issues with a particular plugin, you can email them direct, and they usually get back to you fairly promptly. So there's all sorts of different plugins, and if you get a bit of time, it's sometimes worth having a bit of a trawl through the plugins just to see what various plugins might be of use for your workflow. There's heaps of free data sources. In the last few years, there's been a huge increase in the amount of data available online and free of charge. If you're looking for Australian data, for example, you use a data.gov.au site, or for a particular state in Western Australia, for example, use the data.wa.gov.au website. The West Australian Department of Mines and Industry Regulation and Safety have a large amount of downloadable data, as well as links for accessing data live from their website. For worldwide data, I suggest starting with the NASA Earth Explorer portal. This has heaps of content, including digital elevation data, ASTER, Landsat, and Sentinel-2 satellite data. You'll need to register on the Earth Explorer portal before you can download these things, but it's a free registration and is active almost immediately. The European Space Agency, or ESA, runs the Copernicus Data Hub, where the data from the Sentinel satellites can be accessed. Sentinel-2 data is especially relevant for the Earth sciences, but I'll discuss a bit more about that later. A few abbreviations that are useful to remember for online links are WFS, WMS, and WMTS. WFS stands for Web Feature Server, where the data is in vector formats like points, lines, and polygons. WMS is a Web Map Server link, where the data is in a raster format. And WMTS is a tiled web map server, such as Google Maps, where the raster data is downloaded as needed into the map window when the area is panned around. So this is an example of the data.wa.gov site, and you just click on the data tab, and you can do a search. This is an example of a web feature search for roads, and then you copy that URL link, and that goes into the web feature server tab on the web links in QGIS. This is an example of adding a web map server link in QGIS via the data source manager. Click on WMS, click on new, add a new link, and put the URL in the URL box there. This is some examples of Landgate imagery. Landgate is a West Australian lands department, supplies all land information. And this is an example of some of the imagery they have available. This is a scale of about 1 to 4,000, so you can see the quality of some of this stuff is really quite useful. And if you need to extract this particular part of imagery, for example, you can go via the file export option, and you can save that particular snapshot as a located georeferenced file. Geosciences Australia has a wide variety of data sets available for download, or as web links. For example, there's heaps of digital elevation data at 90 or 30 meter resolution, and there are many other data sets available on the GA website. QGIS reads both ArcView shapefiles and MapInfo tab files, but can't read their styling information because this data is locked in proprietary data formats. For ArcView, the styling data is contained in the LYR sidecar files, and in MapInfo, the data is embedded in the files. The spatial extent of the data is correct, but no styling information is preserved when you bring it into QGIS. North Road Consulting has developed a converter for these LYR files, and if you ever need to convert a lot of ArcView files, then I would strongly recommend you contact North Road Consulting and talk to them about the SLYR converter. With point data, the easiest way to import new data is via the comma separated variable or CSV file. Make sure you check the preview window when you're importing data to make sure QGIS is assigning the correct data type to the fields. Data can also be imported from Excel or other spreadsheet formats. The really important thing about bringing data into any GIS system is to know the projection of your data. Any GIS data you receive must have an identifiable projection attached to its coordinates. Otherwise, you cannot determine which projection to use to add it to your map, and therefore your data may be incorrectly located. The GeoPackage file format is a new default file format for QGIS. QGIS can still read and write other formats such as shape or tab files, but the GeoPackage format has some big advantage over these other formats. GeoPackage files can hold both vector and raster data, including their style information, as well as QGIS project files. This means you can now create projects with all the necessary data and styling information all in one file that can be shared amongst others. Note, however, that the GeoPackage file itself is currently only single user access, so would not be suitable for server access by multiple users. Layers can be loaded into the map window by dragging the file from the browser panel onto the map window. If QGIS has a problem identifying the projection information for a layer, for example, it'll flash up a yellow banner and say it has defaulted to WGS 84. This can be easily corrected by double-clicking on the layer in the Layers panel and then changing the coordinate reference system to the correct one. There are all sorts of other different file open options. You can go via the data source manager here, as we discussed previously. And when you're importing a delimited text file, for example, this is a located data file for a magnetic survey. You can describe which sort of what the file format is. In this case, it's a space separated file, and you can tell it whether it's got point coordinates and what the coordinate reference system is, and check that the bottom part of the sample data window is correct before you import it. QGIS is a plugin called Spreadsheet Layers to import Excel and other spreadsheet files into QGIS. This plugin, when installed and enabled, is available under the Add Spreadsheet Layer option from the main menu toolbar. Individual tabs can then be selected within the spreadsheet files. If the file has coordinate information, ensure the geometry option is selected and that the show fields and attribute table is ticked so that the coordinate columns are displayed in the resulting import. Note that this import creates a virtual file, and if you plan to edit this file, it's recommended you save it as a shape or a GeoPackage file. Geodatabase files are opened by using the Data Source Manager. Select the Vector tab and the Directory option, and then select the type Open File GDB, and then you can then load your geodatabase files. Data can be selected in the map window or as per most other GIS programs by using the pointer, circle, polygons, or by using expressions. When searching for text data, the expression editor is very powerful. To edit vector data in QGIS, you need to toggle the editing on or off. To enable editing, you highlight the vector layer you want to edit and then click on the pencil icon to turn the editing on. This will then cause the editing functions to become active. If the editing function or icons are grayed out, it means that the editing has not been enabled. The icons will change depending on whether the layer is a point, line, or a polygon. To look at the data in your file, use the attribute table. Highlight the layer in the Layers panel and either right-click to bring up the dialog box and select Open Attribute Table, or use the F6 hotkey. You can also vary what data is displayed using the drop-down menu on the bottom left-hand side. Data can be modified in the attribute table when you toggle the pencil icon, which is located on the far left-hand side of the attribute table window. When you toggle editing on, new options become active. You can add and delete fields, perform searches, and delete rows when in editing mode. Just make sure you select the correct column in the left-hand drop-down box so that you're editing the desired field. By selecting by expression options, the yellow square with an epsilon symbol in it, this allows you to select textual data using expressions. This is very powerful, particularly if you're not sure how a particular item is spelled. Select the fields to be searched using the field and values option in the center panel. Double click on the field you want to search in, and it'll be added to the left-hand panel. Choose the operator, for example, equals, and then use the right-hand side panel to either load all values or 10 samples from the search. You can also type the name into the values search box, and as you type it will show you the matches to your typed text. Double click on the selected item and it will be added to your expression, and then just press select. Once the items are selected, you can save these items by using export save as selected features as option. Geological symbols in QGIS can be either fonts or SVG files. SVG files are scale vector graphics files, and they are simple files which can be edited in programs like Inkscape. There are some TrueType fonts available, like Esri fonts, but these are proprietary and their usage may be restricted. Using SVG symbol files do not require the use of any proprietary symbol font sets. There's a huge array of SVG symbols available for free use on the internet. The New South Wales Geological Survey provides SVG files to accompany some of their geological products, and these are free to use. Both geological symbols and geological pattern files are available as SVG files, and the links to these can be found on my website. Here's an example of some of the USGS symbols that have been created as SVG files. The file number is referred back to the reference number on the left-hand side of this table, and is based on the US publication FGDC Digital Cartographic Standards for Geological Map Symbolization. A copy of this is also available on my website for anybody who's interested. It goes through how all these symbols are created from a cartographic point of view. This is an example of some of the USGS pattern fills that are available. And again, the links to these pattern fills are on my website, so please feel free to download them and use them. The SVG patterns can then be used for the polygon fills. The size and color and rotation of the pattern can be changed as required. Some SVG fills do not allow color changes. SVG files can be created or edited using the free Inkscape program. So if you have a particular fill that you can't change the color of, you can go in there and edit that particular style with Inkscape to allow a color to be assigned. The polygons can have multiple layers to allow for colored polygon fills and overlays of patterns with various transparencies. The Style Manager is available in the top icon menu bar and allows the user to see what styles are located in the QGIS and allows you to import or export customized styles. In this example, I have a selection of the polygon fills for the bow 1 to 100,000 geological sheet and have tagged each one of these with a bow tag. I could then export these tagged polygon styles as an XML file, which can then be passed to other users to use in their version of QGIS. Origin structure symbols can be easily plotted in QGIS. In this example, there's a column for strike, and you can instruct QGIS to rotate the symbol by the amount in the strike column using a function called the data-driven override. There are numerous data-driven override buttons on various styling options. You'll note that there's a square box to the right-hand side of both the size and the rotation fields in this screenshot. To activate the rotation option, you use the drop-down override box and then select the column you want to use at the rotation amount, in this case the strike, and when the data-driven override box is active, the button turns yellow. To find out the SVG symbol name, you can use the SVG symbol selector, and when you hover over a symbol, the file name will be shown. This is an example of the Lissadell 1 to 250,000 geological map sheet in Western Australia, with polygons filled with colours and patterns. Remember to save any style changes as they are not automatically saved within QGIS. QGIS also has legend options as part of the print layout. You can have multi-column geological legends. You can reorder the various layers and various subsections within the layers. So it's relatively flexible. Raster data comprises gridded data and located imagery. This is an example of Sentinel-2 data from Central Australia showing the Goss's Bluff impact structure in the upper left-hand side of the map and well-defined stratigraphy in the upper and lower parts of the image. This image was created using bands 12 in the red channel, band 4 in the green channel, and band 2 in the blue channel. And and these RGB images are easily produced within QGIS. QGIS can import many different raster formats, with the most common being TIFF files, JPEGs, ECWs, and ERMapper grid files. All these types of files are into QGIS. Occasionally, QGIS can't recognize a file's coordinate reference system, and when this happens, it flashes a yellow banner across the map window and warns the user that it has defaulted this layer rejection to WS84. If this happens, simply click on the layer name in the Layers panel to bring up the layer properties and correct the coordinate reference system. Raster files with a JP2 extension are JPEG 2000 version files, where the coordinate reference system information is embedded within the file. These files can be opened by dragging the file name from the Windows browser directly into the map window. Geophysical data, images and grids can be loaded into QGIS providing they are in a format that QGIS can read. For example, magnetic grid files in the ERMapper format are read directly by QGIS. Geosoft grid files cannot be read by QGIS and need to be converted using Geosoft's free Oasis montage viewer. This is a magnetic image of the Ackerman impact structure in South Australia. Located data can be imported from text files, and gridding can be carried out using a variety of gridding algorithms that are located in the processing toolbox. Shading of grids can be undertaken using Hillshade render option in the Grids Layer Property Symbology tab. ASCII data files, like located data, can be imported into QGIS using the Open Data Source Manager and selecting the Delimited Text tab. This then allows the user to select the file format and create a located data file of the geophysical data. Always check that the sample data panel to ensure that the data is going to be correctly imported. Note also that the geometry definitions are correct and the coordinate reference system is correct. Just be careful that if you intend to save this file as a shapefile, long field names will be truncated at 10 characters. So if you have field names with long field names, then you might want to save it as a geopackage file, which doesn't have this field name size restriction. Grid files are usually imported by default as grayscale images. The style of the display can be easily changed in the Layer Properties dialog panel. To change the color of the display grid, open Layers Properties for Layer, and in the Symbology tab, change the band rendering from single band to single band pseudo color. There are a large variety of different color ramps to choose from, and you just select one which is most suitable for your particular application. So here's an example of the ones that are preloaded into QGIS, and you can select any of these color ramps. To create a shaded total magnetic intensity image, for example, I typically duplicate the grid layer in the QGIS Layers panel and change the duplicated layer's render type to Hillshade. Then I make make sure the Hillshade layer is below the grid layer. I then change the upper grid layer to a colored one and make it about 50% transparent. This allows the Hillshade layer to be seen through the colored image grid below the colored grid layer. Over the past few years, there's been an increasing amount of satellite data becoming freely available for the world, such as ASTER, Landsat, and Sentinel. Most of these data sets can be downloaded from the USGS Earth Explorer portal. Another way to search for and download data is using the QGIS semi-automatic classification plugin. This allows the user to search for an area of suitable scenes based on criteria like dates or amount of cloud cover. The semi-automatic classification plugin also provides the user with tools for band ratio and things like principal components analysis. This is an example of the download tab in the semi-automatic classification plugin. It allows the user to select the search area, the type of data, for example, in this case Sentinel-2 data, the date range of search for data, and the maximum amount of cloud cover to allow. The search will return any matching data and displayed in the products list, and where it can be selected and a preview loaded in the map window. There are settings to allow the download of only the data sets that have been loaded as previews in the map window, and a variety of other sort of settings there as well. This is an extract from the Geosciences Australia publication using ASTA data. Once you have downloaded the ASTA data, for example, you can use the band ratio tool in the semi-automatic classification plugin to calculate various band calculations and produce simple min-minimal maps. The band calculations are very easily done by simply clicking on one variable, then an operator and another variable. This is an ASTA discrimination image designed to enhance the surface geology. This was created using a combination of 3 band ratios, band 4 divided by band 7 in the red, band 4 divided by band 3 in the green channel, and band 2 divided by band 1 in the blue channel. You'll note that on the left-hand side of this image there's quite a lot of blue areas. These are fire scars. Most people have used Landsat and ASTA data, but new satellite data is coming in daily from the European Space Agency Sentinel satellite constellation. The Sentinel-2 satellites are particularly useful for geological work with a 10-meter resolution in the RGB spectral channels. To create an RGB coloured image in QGIS, use the raster miscellaneous build virtual raster option, and then you can select which particular bands that you want to combine to create your RGB image. And then you can very easily create these sort of RGB images within QGIS. Making a good looking map is one of the essential requirements of any GIS program. QGIS has a vast array of tools to allow the user to make great maps suitable for hard copy, screen, or web applications. The print layout in QGIS is where you create maps for output. Any changes made by any layout settings are automatically updated in the print layout, and the grids and scale bars are linked to the print layout window. The print layout window and the map window are independent, so a change in one window will not necessarily change the other window. When you first open the print layout, you're presented with a blank screen, which usually defaults to A4 in size. Right-click on the blank page and set the desired page size and orientation. If you're using templates, it's important to set the page size first before adding any templates. Templates are handy for standard layouts, and I have a set of these for AO, A1, A2, A3, and A4 portrait landscapes that are available on my website. Please feel free to download them. These templates are a series of lines, polygons, and text boxes. They can be edited to suit your specific requirements. Please feel free to contact me if you need to discuss any of these particular changes for the templates. To add your map to your layout, you use the Add Map icon and click and drag the area on the layout where you want to place the map. You can have multiple map windows on a particular layout. The scale can be set by using the Set the Scale dialog box, and can be fixed permanently by using the data override to set the scale. The contents of the map window can be moved around the map window without affecting the main map window by using the pan button on the left-hand side. Each item in the print layout has an Item Properties tab where all the available settings can be viewed or modified. This example shows the adding of a grid using the green plus button. This then allows the user to modify the grid settings. As part of the settings for the grid, the user can determine how the grid and coordinates are displayed. Each text box has its own item properties where the content, font size, etc. can be set. Output from print layouts can be to a printer as an image or an SVG or a PDF document, as per most other GIS sort of programs. And if you've got any queries, please don't hesitate to send me an email. There's other information on my website as well. So I hope you've enjoyed this introduction of QGIS for geoscientists. And till we meet again.